Okay, good evening class. While you are watching this video, I'll be solving a lot of questions that will be coming out from your outline, your course outline, okay? So, this video is very important as you are watching the class. Try and engage somebody that you know needs this revision, okay? And then share the link with them so that they will watch it. So, I need to upload this video before the evening revision. You understand? So I'll give myself enough rest before the time. So this video will do a lot, okay? So now I'm trying to do a roundup because I have a compiled outline of all the courses, alright? So if I'm able to finish MTH102, I'll also go ahead and do the MTH101, okay? But let's see what the time has for us. So now, very quickly, in order to summarize that with one, I'll just do a very quick question now. Alright, I believe you can see the question I have put up on the board. So, before I solve this question, I have done a quick understanding, like, a breakdown of the topic function, okay? So, it's on my page, you can quickly go there and look at what function is really in terms of real life application. So, let's solve this question very quickly. So, given that f of s, alright, is 5s minus 4 and g of s is s power 2. Now, the question says, what is f of g? So, I'll quickly solve f of g and do a background explanation just to summarize it. So, the meaning of f of g is just as, when you have f of x given as 5s minus 4, alright, that means this is how the operation goes. So if I'm going to have an input of, let's say, minus 2, that input will give me 5 times minus 2 minus 4, 5 times minus 2, that's minus 10, minus 4, is going to give me an output of minus 4, minus 14, okay? That's how the operation works, based on this formula, alright? And also, likewise, if I have g of s as s power 2, g of, let's say, minus 2 also will give me what? Minus 2 all this by 2, that is 4. Alright? Now, in this question, I'm having a combination of two different functions. You already understand how to operate the function. When you say f of x, which is the same thing as this, f of s, it means whatever s represents, I'm going to put it into the formula or into the function of f, okay? So now, if I now have f of g, it means whatever g represents, I am going to put it into the function of f. So what does g represent? G represents x raised power 2, alright? So if you slot in this x raised power 2 into, first of all, let's write down the function of f by the side. Okay, so the function of f is what? 5x minus 4. Alright, whatever g represents, which is what s squared, if you slot it into this, alright, you understand, you kind of replace this, alright, that will give me that f of g is given as what, 5s squared minus 4. What just happened? I just replaced this s raised by 2 into this x. That is what it is. That's just our answer, okay? So now, what are the other questions you probably will see on exam day real life? Now, you probably will see f of g of 2. F of g of 2 means you quickly slot in 2 into whatever g represents, and we've done that. Okay, g of 2, that means that going by this formula, that means that you put 2 here, that will be 2 raised by 2. Are you getting it now? So that gives us 4. So it means that this whole expression has become f of 4, which is the same as f of 4, like this. Are you getting it now? So f of 4, that will mean slotting 4 into whatever what f represents, or the function that f represents. That will be what? 5 times 4 minus 4. 5 times 4 is what? 20 minus 4, and that gives you 16. You understand this? You can always play back to understand it very well. You understand what I'm saying? So this is what we get when it comes to, so when we are combining functions like this f of g, or probably another function f of g of h, The combined function is called opposite function. That is one and one function, okay? So we have onto function and we have one-to-one function. These are another things that you need to understand, okay? Now, you know, your input, the collection of your input or the set of your input gives you what we call, that's our what? Domain, right? Then the output will give you what we call what? Co-domain, right? Collection of all these words that are now, you know, the collection of all these words that are now part of the, the words that are given from our question is called range. You just need to understand the meaning of range. Alright? I taking it out. So because of time, I'll just do other things, okay? Alright, there are different kinds of functions, okay? But it's good that you know some, important function, like the quadratic function. What's the quadratic function? The quadratic function is literally the function that the highest power is just 2, okay? The form of the quadratic function is just, f of s, you have the power as 2, probably you now have the what? Let's say as squared plus bs plus c. This is a quadratic function. Now, the quadratic function will go this way or that way. This is a positive quadratic function, alright, and a negative quadratic function. I will together now. Alright. So other functions, you have your let's say exponential function. Exponential function goes this way, alright, or that way. Okay? Then logarithmic function goes this way or that way. Alright? So we will now have polynomial function or what we call it? Functions that are what? With polynomial form. Let's say polynomial of degree 2. Or let's say degree 3, degree 4. For degree 3 means that the highest power of s is this part 3. Okay? So for degree 3, the function will go like this and come back this way. Degree 4, it will go this way and come back and have another one. You understand? So you don't have to understand the different functions back. So let's go to other things. Now let me quickly solve this question. And because it's almost dark, I'll quickly solve this question and just do some other important things. So now this is evaluate what the s squared plus 2s minus 3 as s tends to 3. We're going to see this kind of question, okay? How to solve it. Now how to solve this is what? You just what? Substitute the value of what? Of 3 into this, okay? So we have the, right? The what? 3 is what? 2 plus 2 times 3 minus 3. And at the end of the day, what do you have? 9 plus 6 minus 3, and you have your answer as what? 12, right? Good. So in the limiting function, alright, all you're doing is, you're slotting the value of whatever the value of s is moving to. At the end of the day, what happens? You get your value, okay? For the case where, the value of s is going to be slotted in and you have 0 as the answer, you just look for a way to manipulate it. Alright, either by factorizing and all these methods that we have explained earlier. This is just a summary class, okay? So now, quickly, I want to quickly go into what we'll be doing tonight. Alright, we're going to be, evaluating integral calculus. But before I go into integral calculus, let's just explain or summarize everything under calculus. Calculus, when you have the calculus of, let's say, y equal to, right? A s raised by n, if you differentiate y with respect to s, it will be what? A n x raised by n minus 1. So, for example, if I differentiate 2s, I will have 2, right? If I differentiate 2s raised by 2 I will have 2 times 2. And what? 4s, right? You know that. Now, if I differentiate 2s raised by 3, 3 times 2, that's what? 6. Then 6s, you understand, raised by what? 2. You understand all this stuff, right? Good. Now, if I differentiate a constant, that will give me 0. Right? That will give me what? 0. You understand that? So now what I want to do is, when we have function of function, what is function of function? Let's assume I have y equal to 2x minus 1. But this function has an entire function, let's say, raised by 10. So this is function of function. What do? You go ahead and differentiate what you have inside, multiply on what you have outside. That will give you what? What you have inside will give you 2, if you differentiate is 2. If I explain, that will be what? 6. Then that will be what? 2x minus 1 raised by what? 2. You understand this function of function. Differentiate what you have inside, then multiply by the power, then reduce the power. You understand that? Is that okay? Good. So that is function of function. The next one is product. Let's assume I have y equal to a particular function, let's say 6x squared minus 1 multiplied by another function, let's say trigonometric function now. Let's say sin s, right? Good. So what I'll do is, I'll differentiate this function multiplied by this one. Alright? So differentiate this one, what you have 2 times 6, that is 12. Right? So 12s, right? So 12s, then multiply by this, that will give you what? Sin x, right? That will be perfect. So differentiate this, multiply by this, plus this time around, you differentiate this one now, then you multiply by this. So when you differentiate sin x, you have what? Cos x. So we multiply by this, then we'll start with this first. So that will be 6x squared minus 1, multiply by what? Cos x. That is how to handle or tackle question under product rule. So this multiply by this. If I have another product, I'm still following the same method. Let's say I have another product, let's say root x now. I'll do this. Differentiate 1, multiply by the 2, plus differentiate the next one, multiply by the remaining 2, plus differentiate the last one, multiply by the remaining 2. That's how it works, alright? Product rule. So now, that's by the way, so let's establish something here. So that's product to establish, okay? So now the next one is, let's establish, what do you call it? Quotient rule. I've done that in my video, but I've just summarized the things you did from my personal video. And I know I expect you to go through other videos. Now, quotient rule, we have a situation where, let me use trigonometric function this time around. So, sin x raised by 3, can you see that? X raised by 3 divided by, let me use another trigonometric function, or let me just use with x. Alright? So this is divided by this. I get clear, this is quotient, okay? So what do you do with quotient? You start by, alright, differentiate what you have up first. Alright, differentiate what you have up. You don't have a formula for breaking it down. But the essence of this video is to help you to understand a faster way of doing this. Alright? So differentiate what you have on top first. What will differentiate this? How do you differentiate this? I know that some of you still need to learn how to differentiate this. But let's assume that this is not our question, this is our question. Sin x raised by 3. This is our question now. This is not our question, this is our question now. Differentiate what we have here. How do you differentiate it? Now this is a function of function, what I said earlier. We have a trigonometric function, but inside that trigonometric function, we have what? Another function for s. S is raised by 3. That's another function on its own. You understand? So what you do, like what I said before, you differentiate the inner function, right? Then you now multiply by the outer function. You understand? Differentiate the inner function and multiply by the differential value of the outer function. There are formulas for all these things. But I want to do it in a way that you already understand what the formula represents. Okay? So let's differentiate the inner function. That is differentiate x raised by 3. Differentiate x raised by 3, now what? 3x squared. Alright? So 3x squared. Now differentiate the outer function. What is the outer function? Sine, right? The differential value of sine is what? Cos. So that will be what? That will be what? Cos x raised by 3. Did you get that? So that differentiation is, we differentiate the inner function, then we have to differentiate the outer function. The outer function is cos, but it will still retain the original value of the angle. The original value of the angle is what? X raised by 3. You get that? So that's just it. Alright, so you already understand it. So that means we can now go ahead to do this. So now, what is this? I said, when it comes to quotient rule, you differentiate what is up, multiply by what you have under. You differentiate what is up. So when I differentiate this, remember what I got? I got what? 3s squared plus what? X is part 2. So 3s squared plus x is part 3, right? Multiply by what I have under. Can you see that? So this is v du dx, right? Then minus differentiate what I have under. Now when you want to differentiate this, alright? Remember, I told you in all our live classes, when you want to differentiate, you have to analyze what this represents. Root s represents x is power 1 over 2, alright? Now when you differentiate x is power 1 over 2, what do you get from it? You get what? When you differentiate, you have 1 over 2 x is power minus 1 over 2, alright? You can follow the formula, this formula I'll apply now, you can do that on your own. So what we get at the end of the day, we get what? Right? Y minus 1 over 2 root s is at the end of the day, okay? So, minus 1 over 2 root s, you can always do that, you can simplify this on your own, right? So, minus 1 over, so the part of this minus and this minus, that will be plus. Can you see that now? So, 1 over 2 root s, alright, multiplied by this, that is 5 f is part 3. Can you see that? So, everything all over, you square this one. Root s all squared. That is how to do quotient rule. Differentiate the what you call it, numerator, then multiply by the denominator, minus differentiate the denominator, multiply by the numerator, all divided by what? The square of what? The denominator. You understand that, right? So what do you have now? When you simplify this, you can easily have what? When this multiplied by this, you know what I mean? This multiplied by this, you have what? 2x, right? 3s squared plus what? S is part 3 plus what? Sine s is part 3 or now the square of this is what? The square of this is what? X, right? Then you are still going to multiply with what? 2 root s. So that's what? 2s root s, please. You can always do this in a simpler form on your own. Alright? Then you understand this on simplify. So this is our answer when we differentiate this. The whole idea is u divided ds, sorry, v du ds, I mean, v du ds, right, minus u divided ds, right, all over what? V squared. This is what we have done. Everything we did here, this is what we have done. This is the portion and the denominator. This is the differential value of the portion and the numerator, and so on and so forth. You understand what I mean? Alright? So also, now, if I'm done with, quotient rule, alright, I hope you got this here because that's what I'm looking at for free. Now, if I'm done with quotient rule, what I now need to understand is higher differential value of higher differentiation, alright? Are you getting me now? So higher differentiation, for instance, I can be asked to do 5 pi f of x. 5 pi f of x means the differentiate 3 times, okay? So let's assume I have e raised to power 2x raised to power 2. Now I have e raised to power 2x raised to power 2 as my function of x. Alright? 0 to what? To the power of 2x raised to power 2. How do I differentiate it? This probably will be the kind of question you see tomorrow. So I hope you follow so that you understand. Alright? Let me make the video closer. Alright, so we are having, alright, so now, how do we differentiate this? This is function of function, okay? Now, this is the first function, alright, and this is the second function, that's the inner function. You know what to do. You differentiate the inner function, you multiply by what? The differential value of what? The outer function. That is still, you understand? So, let's differentiate the inner function. So when you differentiate this, we have 2s raised to 2, 2 times 2, 4s, right? That's the value. So now 4x for the inner function. When you now differentiate the outer function, it still remains there. Anytime you differentiate e raised to s, you still get what? E raised to s, it doesn't change. Alright? If you integrate e raised to s, you're still going to get e raised to s. Alright? So that means if we differentiate the outer function, we still have what? Our e raised to 2. Now, meanwhile, this is just the first differentiation, alright? This is the first, what do you call it? First differentiation, alright? So the second one will be F prime. F prime of S, you differentiate, you continue like that, okay? So now at this junction, we now have this like this. This is product flow now. You can see this thing is becoming interesting. This is product flow. So this like this, okay? And you know what to do to product flow. Alright, you differentiate the first one, multiply by the second one, plus differentiate the second, multiply by what? The first one. So let's do that. So let's differentiate this. You differentiate 4s, you're going to get what? 4. So 4 times 0. So 4 0 is equal to 2s is equal to, alright, plus, now differentiate this one, multiply by this. Now when you differentiate this, you're going to get this as the answer. Because this was what you want before. I want to differentiate the result this. So when you differentiate this one, you're still going to get this, right? So when we differentiate, you get this. So that's what 4s 0 is equal to 2s is equal to. Now multiply by this. Multiply by this 4s now, multiply by 4s. So at the end of the day, you have what? 4 0 is equal 2s is equal to. Plus what? 4 times 4, 16s squared, 0 is equal to 2s 2, right? Good. So this is the second differential value. Alright, the third one, s prime s, now the what? S prime s is what? So you differentiate this is very simple, right? So you differentiate this. You know what I mean? You know, this will what? For, you know, when you differentiate this alone, what do you have? When you differentiate this alone, you still have this, right? So when you multiply by 4, that will be 16s, right? New 2s is equal to, right? Plus, okay? Now let's differentiate this. Now this is product 2 as well. Product 2. Why is it product 2? Why is it not product 2? This is just a constant or just a coefficient, right? Just a coefficient. But here we have function and function. That's product 2. This is not product, right? But this is product. This is like this. So it's a product 2. We're going to treat it like product function. Okay? So what you do in product function, you differentiate the first function, function of s, which is what? 16s is equal to. This is 16s is equal to. I hope nobody see there. Alright? So 16s is equal to. Now what we get to do that? What we get to do that? 16s is equal to what? 2 times 16, that's what? That's 2x, right? Multiply by the second one, that is 0 is equal to 2s is equal to, okay? Plus, now you differentiate 0 and multiply by this. When you differentiate 0, go back to this, remember. Whenever you differentiate 0, this is what you get. So we are using this whole thing to multiply this. You understand? This whole thing to multiply what? 16s. So what would that give us? So 4 times 16, that would what? 64, right? 64. Alright, x times s is equal to, that's what? S times s is equal to, that's what? S is equal to. Alright? Okay? So what's that? What's that? Remember what I mean? We differentiated this and multiply by this. That is what we want to do. So now we are differentiating this and multiply by this. When we differentiate this, we will get this. So that's why we are using this to multiply by this. So this times this, 64, s times s, that's what? S is equal to, they will now have what? U to the power of 2s is equal to. I hope you understand that. Alright? Okay, the board didn't capture that. Didn't capture that. Can you see that now? You can see what I'm avoiding, that hole in the board. But you can see that, right? So, okay, so this is just that. So I will stop here because we just summarize with 1, 2, 3, 4, 5, I think to 6. So what left is what? Integral calculus, okay? And application of all these things. So we'll do that at the light class. Then the light class. Thank you. Hello guys. Okay, please encourage what to do, okay? Share this video to your friends, your family, okay? And subscribe, okay? Please encourage what to do. So maybe there are some other people that are, you know, they have need of some of the videos on my page. Please share so that they will be part of it. And tell them to subscribe, tell another person, and tell another person. Alright, bye bye, Mr. Brain.